One of Createc's reasons for being is to create new technologies that we use to improve the way we go about nuclear decommissioning. One of the big challenges with nuclear power is what do you do when you've finished with your plants and equipment? They're typically radioactively contaminated, which is a hazard to human health, and that means we can't always do these tasks manually. We need some way to get in there and decommission these things without exposing people to the harm of radiation. Createc's been developing a modular robotics technology through a project called Elephants to Ants. We liken the machines that are used today to elephants. They're big, complex, single-purpose machines which are what they are and do what they do. An elephant can only be an elephant. Ants, on the other hand, can achieve many different tasks using configurations of many simple units to get something complicated done through cooperation. And Elephants to Ants is about precisely that. People are so adaptable. The fundamental objective of the project is to answer the question, can we achieve the same level of flexibility that humans have in decommissioning by bringing together a whole team of small robots to make an agile system? Standing by. All of the robots and tools that we use in Elephants to Ants are controlled remotely from a VR control room. We want the people using the system to be experts in decommissioning, not experts in robotics. Both the system integration, but also the user interface needs to be simple and natural. Everything in the system can be accessed through a pair of VR controllers to actually direct and control the motion of the individual robots through gestures, to flick through the different software modes, to make measurements, to interact with the data in any way. Just like your mouse and your keyboard is enough to use all of the software on your desktop computer, we found that with the right interfaces, one set of VR controllers is enough to control and interact with all of the sensors and all of the data and all of the robots in the project.
First operation, control to you in 3, 2, 1, wheels.
This week we're running 5 sequential one-day demos to demonstrate the whole process of end-to-end decommissioning, from first entry into the cell to filling up a waste container with sorted, characterized and packed waste. The demonstration begins with the characterization of the contents of the cell, trying to find out the exact three-dimensional shape of what's currently in there, what does it look like, and what's the status of its radiological contamination, because that's going to determine what we do next. We achieved that using 2 robots which are built out of our ANT modules. The first one contains a wheeled platform with a single arm and an envisaged gamma camera, and the purpose of that is from ground level to obtain what data it can on the 3D shape and the characterization, but also the operator can install sensors around the cell. Those can be cameras to enable views of what's happening from specific directions or lights, but they can also be RGBD cameras, so that's a 3D camera. Part of that 3D model becomes live. We can look at it from any angle, but we see what's actually happening now. That both produces color-rendered 3D point cloud images which are used in VR later for visualization, but it can also produce radiation measurement data which can estimate the activity level of each of those points, and that means we know what waste category those items are going to be later when we start to cut and move objects down to the waste handling area. Once the sensors have been deployed, the robot simply withdraws from the room and tucking away any cables that might pose an obstacle to future operations. The main target of the decommissioning for this cell is 2 vessels which are high up in the air, so in order to get some data on those, we introduce a new system, a MEUP, which gives us access at height, and a snake arm robot. The MEUP can only be deployed into the cell thanks to the sensors that were installed by the small robot, because the access is so tight that excellent perception is needed by the operator to do that confidently. Once the MEUP's in the cell, it can then raise up and deploy the snake arm through the gap between the vessels to look behind and into small apertures in the vessels to investigate their contents. One of the fundamental challenges which has to be solved when we actually begin decommissioning the cell is how do we lift some of these heavy items down from their current high location to the floor where they can be processed as waste. One of the ways that we can do that is by installing lifting equipment. The next demonstration involves taking some winches that we've adapted to be also controlled through the RDOS software interface, and then installing them on beams that are already existing in the cell using a combination of the robots that we already have. The MEUP again, which provides the ability to lift the winches to the height of the beams. A small turntable on the top deck of the MEUP holds the winch assembly in place while it's being transported into the cell. The turntable can be operated by a pair of Franker cobots which are mounted on the back of the platform facing in. On the ground, the MEUP is approximately aligned with the beam where we want to install the winch. The MEUP is raised until the winch is quite close to the beam. We can fine-tune the position using the linear stage actuation of the top deck of the MEUP. raise just a few more centimetres so that the clamp engages with the beam, and to manually tighten the clamp itself. The soft hands that we use on the end of the Franke robots developed at IIT give us the ability to do very fiddly tasks intended to be completed by human hands using the natural, intuitive and robust hand end effectors on the end of the robots. From there we can take the hands away and then just simply drop the platform to leave the winch suspended on the beam. Our third demo is preparing to plasma cut the vessels and then actually cutting a piece off and lowering that piece down to the floor in a safe and controlled manner. The first step in the process is to connect the piece that we want to cut off to something so it doesn't drop. In this case, we can do that using a magnet and attach the magnet to the part of the tank that we intend to cut away. That's mounted using a Franke cobot that can feel the tank and stop at the appropriate point. In this case, because we don't want to drop the cutting torch, we opt to remove the soft hand and replace it with a permanently attached cutting head. We plasma cut the piece away using again the ability of the Franke robot to feel what's going on so that we can use a standard handheld drag cutting mode for the plasma torch. Once the cut's complete, the part falls onto the winch and we can then lower that to the ground. For more complex tasks where the waste item has to follow a more complex trajectory than straight down, a piece of software enables us to synchronize the action of two winches together. This enables us to lift items up and over other obstacles on the way to the ground rather than dropping them straight down. Our fourth demo was waste handling and packing. What we now need to do is to get those waste items to our waste handling station so that they can be further processed. We pick up the pieces using a ground vehicle with a cobot mounted on the front. Either using its own fingers or a magnetic grip tool. The robot then transports that over to a waste storage area, which is a shelving unit which is accessible by the waste handling robot. Waste items are scanned and sorted and placed by a fixed robot. The fixed robot is a Yaskawa welding robot that we've repurposed so that it can move both automatically as it was intended to, but can also be controlled in real time through the VR system. The user scans parts by picking them up and placing them on a 3D scan station, which builds an accurate 3D model, but also checks the radiological status of the part. And then a piece of software called NewPlant, which is also integrated with VR, analyzes those parts, determines the most efficient packing, and advises the user which part needs to go into the box next and where in the box it goes. It communicates that to the user through an augmented reality overlay presented through the VR interface. So the user's task is simply to pick up the part and line it up with the wireframe model that's shown in VR. Sometimes we may not want to do all of our cutting high up, and in those situations we need to be able to manipulate larger objects and bring them down to an area where it's easier to process them. We demonstrate that we can do that in Demo 5 by using one of the large winches capable of lifting the vessel, but what makes it challenging is that the vessel itself is not capable of being dropped down the gap between it and the frame that it's standing on because of the trunnions that support it on either side. The first step in the process is to mount one of the heavy lift winches directly above the vessel so that we can support its weight. Once the winch is tight, it's possible to cut away the trunnions. The cutting we do using a laser mounted on a snake. In this demo we didn't really deploy a laser, but we demonstrated that we could achieve the access and the motions necessary to execute the laser cut. Once the tank is free, we're then able to guide it to the ground using the Franke cobots. The winch lifts it a little, then the cobots grab it and gently rotate it through 90 degrees before holding it steady so that it can be dropped smoothly through the gap without jamming the trunnions on the way. Once it's through the gap, the Frankes can then release it and it's lowered all the way to the ground.
We're happy with that, over.
The really exciting thing about the project has been, now that we've got the base technology in place, how quickly we can put these demonstrations together. In just 1 week, it's been possible to continuously reconfigure robots every day to complete a completely new demonstration each morning and then be ready after one afternoon's work to do the next demonstration the next day. That really proves what kind of a speed up we could get from using these robots in reality. We don't have single-purpose systems. We have a toolbox that we can reuse again and again in any decommissioning tasks. The next step has got to be taking some of these technologies to a real nuclear site and putting them into practice, using them to do tasks that we might have done manually, and really proving that these technologies have got the maturity and the capability to not only do what's being done today, but to do it better and to do it safer.